The empty set can sometimes seem as sort of a useless construct. Why would we want to talk about something that's empty? Well, when we think about computers and we think about folders in your computer, have you ever created a folder that's had nothing in it? Well, I know I have a lot of those sitting on my computer somewhere. So first of all, let's recall that an empty set is a set, but it contains 0 elements in it. And we have 2 ways of denoting that. One way is this big 0 with a strike through, and another way you could write this is 0 with a strike through is just equal to the set containing no elements. So these 2 things are interchangeable. Now, if I have a folder, let's suppose I have some folder, and maybe this one does contain some files. I'll call this one my pics. And maybe this has some pics called 1.jpg and 2.jpg. So my pics would be the set containing 1.jpg and 2.jpg. Now for any set, the empty set is always a subset. If we think about what that means, that simply means that is it the case that this set right here that contains no elements, that all of the elements that are in there are also in the set mypics? Well, since there's nothing in there, there's nothing to look for, and since there's nothing to look for, we can say that yes, everything that is inside of the empty set is also inside of mypics. So that is a true statement. The empty set is always a subset of any given set. Now let's look at a folder that contains nothing in it. So we'll call this folder no pics. Now inside of no pics, I'm not going to have any branches coming out because no pics is simply a folder with nothing in it. So it is in its own right the empty set. Therefore I could write that no pics is the empty set. So already we can see that this is going to be somewhat useful because computers do contain folders that when they're created contain no elements in there. Now on a more complex scale, this is often something more along the lines of what we see. We have a folder, and we'll just call this mypics, and inside of that folder not only do we have files, but let's suppose that we also have other folders. And we'll call this folder dogpics. So these are just pictures of a dog. And so maybe here we have d1.jpg and d2.jpg. Also, inside of mypics, suppose we've created a folder that just contains nothing in it. Maybe this was a future, maybe this was going to be wedding pics, and we haven't quite gotten there yet, so this folder contains nothing in it. So how would the hierarchy of mypics look? Well, mypics in its own right is a set. So we could write mypics is the set, or is the folder, and what does that folder contain within it? Well, it contains 2 other folders. It contains, or 2 elements. We can think about this as having 2 elements. And those elements in their own rights are sets. So it is possible for a set to be constructed or built upon other sets. So inside of this folder, we're going to have dogpics, which is a set, and we're going to have wedpics, which is a set. Okay, so that's the simplest way we can write it, but we can extrapolate on this because dogpics is equal to the set that contains d1.jpg and d2.jpg. So all I'm going to do now is, rather than to put in dogpics, I know that what dogpics contains is it's a folder or a set, and it contains the 2 files d1.jpg and d2.jpg. So we have a set nested within another set. And this is a great way for a computer to be able to keep track of the hierarchy of folders because each folder is represented by a brand new set. Also inside of that we have wedpics, and wedpics is simply the empty set. so I can just replace the word wedpix with the empty set. So I have a set that contains two sets. Or in translation, I have a folder that contains two folders, one of which has some files in it, the other of which does not. So let's ask some questions. Is it fair to say that d1.jpg is in mypix? Well, if I were to double-click on this folder, would I see the file d1.jpg? I would not. I would instead see two folders, one called dogpix and one called wedpix. Now, underlying mypix, ultimately I could get to d1.jpg, but d1.jpg is not contained within the file folder. Again, if I double-click on that, I'm going to see two additional folders and no other files. So what we would say here is that no, it's not an element of mypix. Similarly, we could say the same thing for d2.jpg. It is not an element of mypix. Now, what we can say is, or what we can ask is the folder, or is the set containing d1.jpg and d2.jpg? Is the folder containing those two files an element of mypix? Well, that's the same thing as saying, is dogpix an element contained within mypix? And it is, because if I double click on this folder, I will see the folder called dogpix. I could also say that the empty set, or the vacuous set, is an element of mypix. Or, alternatively, I could say that wedpix is an element of mypix, because if I double-click on mypix, I'm going to see one folder that contains some files and another folder that does not. So we could say that not only is, in this case, the empty set a subset of mypix, that is, everything that is inside of the empty set is also inside of mypix because there's nothing in the empty set. But in addition to that, I could also say that the empty set is an element of the set called mypix. And this is why, a lot of time in computer programming, we have trouble subsetting lists. You may have experienced this encounter before where you try to find an element called d1.jpg within a list or some sort of array, and you can't locate it because that file is actually nested within another list within the list. So this is where you get into lists nested within lists, or in our case, sets nested within sets.